All right, so what we're looking at this time is the example C down here. So we've got to check first of all to make sure that we have a linear function. So 2.3 to 2.8 is 0.5, and 2.8 to 3.3, that will be 0.5 as well. So it looks like our dependent change is 0.5. And then we check our independent change, 1 to 2, a 2 to 3, so it's 1. So there we have 0.5. Well, how do we need that as a we need that as a fraction, don't we? Because that's what our slopes are supposed to look like. So that's going to be 1/2 over 1. And that means that we have 1/2 divided by 1. And that's your trick, remember, for simplifying fractions with fractions. Change it into a division problem. So that says 1/2 times the reciprocal of 1, which is 1. And so that's simply 1/2. Or you could have gotten that another way, but I wanted to take the opportunity to go through that trick just in case. All right, now once we have the slope, we'll go ahead and plug into point slope form. So we have y minus whatever our 1y value is, and we'll just choose one. Well, let's go ahead and choose 2.8, okay? So 2.8, and then that's equal to 1/2, and then times our x value, our independent, which is x this time, minus, and then I use 2.8, so I'm going to be using 2 here. And so now I distribute, so I have y minus 2.8 is equal to 1/2 times x, which is 1/2 x, and then minus 1/2 times 2, which is equal to 1. And then I'm going to move the 2.8 over, so we have plus 2.8 there and there. And now we have y is equal to 1/2 x, and then plus, and 2.8 minus 1 is 1.8. And so there's our new equation. And now we'll write it in function notation. F of x is equal to 1/2 x plus 1.8, or we could write this as 1 4/5, right, to make it all in fractions. And then if you wanted to, we could even do it in an improper fraction, or you could just leave it alone. It doesn't really matter. So either one would do. And so there would be my function. So hopefully that one went pretty well. All right, let's take a look and see if we have any other problems in which we want to do in this section. So our next problem is looking like example number 32, or exercise number 11 from your book. So that means that we need to go open the book. All right, at this time, Lehman is going to take a look at Lehman's going to take a look at linear regression. And remember, linear regression is a way of fitting a model to something that's approximate. So we're going to try to find a line that approximates real-world data points. And I'm not going to go into regression in any great deal, and I'm not going to have you do a lot of these problems. But I did want to take a look at exercise number 11 because I thought it gave you a good idea of what the regression was about. So here's the exercise. And what it says is in exercises 11 and 12, consider the scattergram of the data and graph the model y equals mt plus b in the indicated figure. And then sketch the graph of a linear model that describes the data better, and then explain how you would adjust the values of m and b from the original models that would describe the data better. So I just want to briefly talk about this. So you see, this doesn't really go along these points very well. So what I would do is I would take and I would try to draw a line through this way, right? So that they would hit more of the points and be very close to a lot more of them. And in order to do that, what we would be doing is we would be making the slope steeper, right? It would be a bigger positive slope, and then our y-intercept would be probably a negative value, maybe 0, but probably a negative value, or a very, very small positive value. And that's what would make a better fit to this model here. And that's all I really wanted to say about that.